Today, 8.8, reciprocal trig functions. Okay, so actually there's all 6 trig ratios existing. So far, we've been focusing on the first 3, which are sine, cosine, and tangent. And each of sine, cosine, tangent have its reciprocal functions, which we call cosecant, secant, cotangent. Okay, as you see from this slide, sine ratio is opposite over hypotenuse, and its reciprocal function, which is called cosecant, and the way that we notate the function as notation is CSC, cosecant, is hypotenuse over opposite. That being said, the ratio that gets sine, it's reciprocated, and then the reciprocal of it is gonna be the cosecant, and then it's hypotenuse over opposite. Same matter, cosine has its reciprocal function, and we call it secant. And notation is SEC, and as you can see, that's the reciprocal of adjacent over hypotenuse, so secant is hypotenuse over adjacent. And also the tangent is showing cotangent as its reciprocal function. And as you see, the ratio of cotangent is adjacent over opposite. Then if we sum all of them, reciprocals is just the ratio upside down. Then we can conclude the relationship between cosecant and sine, as we can define cosecant being 1 over sine. The step showing between this equation down there, the bottom part. So that's applicable for all other 3, right? The other 2. So all 3 original trig functions, trig ratios, sine, cosine, tangent, it's applicable for their reciprocal, cosecant, secant, cotangent, it's the same. Okay, then now we have another table that depicts what we just discussed from the previous slide. So sine is 1 over cosecant, and cosecant is 1 over sine. And cosine is 1 over secant, and secant is 1 over cosine. And tangent is 1 over cotangent, and cotangent is 1 over tangent. Then, when we were learning about tangent, and the tangent identity was proven from the unit circle, we can write tangent as sine of the angle over cosine of the angle. Then in that matter, cotangent is the reciprocal of tangent. And instead of sine on top, cosine on the bottom, cotangent as tangent reciprocal is also a cosine over sine. And the proving steps is added on the bottom of that table, as you can see. Okay, any questions so far? Okay. Then now, as we already had all the other functions, and we will observe how the graphs of this new three functions, the original functions and reciprocal here. Since cotangent of x is undefined for x value when n times pi with n being integers, its complete graph has a vertical asymptote at these values. And you can connect this fact into the key features of tangent function. So now, this is the tangent graph as you remember from 8.7, right? The graphical key features that you can compare from the tangent and cotangent, as you see, the tangent graphs had the zeros at n times pi, but in that matter, if you investigate how the reciprocal works, and it's gonna make the cotangent values, because it's upside down, undefined, then now where the tangent function used to have the zeros, then now the cotangent function graph will have the vertical asymptote. And in between those vertical asymptotes, and you will have the cotangent graph pass through the x-axis, and that's where the tangent graph used to have the asymptote. Now the cotangent function will have zeros. And also, since we are dealing with the reciprocal values, and as you see, the shape of the curves are reflected. So once again, the way that you can compare the cotangent curves and tangent curves are here. So those values, the tangent graphs that have zeros, in cotangent graphs, it will have the vertical asymptote. Where the tangent graphs have the vertical asymptote, where that's the exact same values where cotangent graphs have the zeros. And the direction and the shapes of each curves that you can observe for cotangent graphs, and they are reflected from the shapes that you have tangent. But that's algebraically or the mathematically that you can expect, because the difference between tangent and cotangent is the reciprocal. So it literally changes the numerator and denominator from each other's, and we can see these graphical key features consequently happening in the comparison between two graphs. Okay, then let's move on to the other two graphs, cosecant and secant here. To graph the cosecant and secant function, we use reciprocal identities based on cosecant is 1 over sine and secant is 1 over cosine. So later, if you have your own study time, then you can utilize the decimals and you can see the steps by yourself. But we can conclude that cosecant x graphs are kind of parabola, it happening repeatedly over and over around the blue line that you can see from the image, which is the sine. So compared to parent function of sine, the parent function of cosecant, that is sine's reciprocal, will happen in the red highlighted curve, but it's exactly around that parent function of sine. So if we see continuous form of cosecant, and it's gonna have this type of shape, and also you can see there's gonna be vertical asymptotes as well. Then this is a very similar manner for the secant. So the secant curves are happening around cosine graphs that is currently highlighted in blue. So that's first one period that you can verify there. It's still 2 pi period, but the red highlighted curve will indicate how the secant graph going on. And also the positions are gonna be around where the cosine parent function is happening. So if you see continuous region, then this is secant, and you can picture the parent graph of cosecant will happening between those parabola shape repeatedly happening there. Okay, again, this whole section includes very comprehensive and complicated concepts here, and make sure you watch all the recorded videos and use scout videos until you understand the relationship graphically and algebraically all over again, okay? Then now we can compare cosecant and secant graph at the same time. So now the top left corner is the cosecant, because we can literally see this is the sine graph happening between the curves, right? So this red one is y equals cosecant x here. And now same manner, I can tell the bottom right corner one is secant, because I can graph cosine in blue there, right? Then the red one is obviously y equals secant of x. So that's the trick for you guys to verify which ones mean which, right? Save this. Okay, then we have 2 examples following, and that's all for today. Okay, example number 1, and this is directly copied from the practice problem. Now we are given with an image of a graph. Then you're supposed to find the equation of the given graph here. So first key features that you can see, this is totally different from either cosecant or secant because they are not the parabola type of the curves. So now we can aim to have either tangent or cotangent. And as you can see, the direction and shape of each curves that you can observe from there, this is obviously cotangent, right? The tangent was going the other way. So now we can expect this one to be y equals something, a, b, c, d values around there. And at least we can define it with cotangent there. So that's the first step. Then now I can observe at least there's no vertical shift, because based on the center of the reflected point of each curve, they're all in the x-axis here. So now I guess the d value will be just 0, right? And if I just take those the zeros on the x-axis as it is, then if I compare this with the image of the original cotangent, let's rewrite it here. Y is its cotangent here, right? Now, compared to original, parent function here, the parent function has the period length pi, but we can see instead of pi, and if we just focus on the label here, so if this is 2 pi, and then this must be pi here. If this is negative 2 pi, this must be negative pi here, right? Then now compared to original one, and this is horizontally stretched twice longer than original period, right? Then now one period from the transformed graph is 2 pi instead of just parent function graph period pi. So then we can calculate the actual b value positioned in front of the x on the equation like this. So it was originally pi over b, then now transformed to b, the one period is 2 pi here. Then we can calculate it over 1 and cross multiply. So b times 2 pi is 1 times pi here. And then we can solve it for b. So b is pi over 2 pi. And then cancel pi and pi. And then it's going to give us 1 over 2. So then I can take 1 over 2 as the b value. This is a b value, right? Then it's going to be 1/2 in front of what? The x. And to be clear, we can put the parentheses over there. Then also we are comparing the positions of vertical coordinates there, and then we can verify there's no vertical dilation. So then a value is 1, so we don't really have specific a value. And also we already see there's no vertical or horizontal shifting going on, and that makes c value or d value not really specifically anything. So then the equation that you are given here is just this, right? Save this. Any question? Okay, if this one doesn't really click directly momentarily, then you can still watch the recorded video repeatedly again, okay? Then let's move on, example number 2. So similar way, now I can also see this one is also the cotangent, right? Then I can verify the reflected point here. Reflected point are up there. So then that's where your midline of the graph passing through. So now I can verify my midline point here. So this is midline where y equals 2. So that means there's vertical shift up to, right? So then d value will be positive 2. And also this is cotangent graph before that. Then now we are making sure all the other a value. Then if you compare from the original function here, no vertical stretch, right? And no horizontal stretch either, because you can see from here. So if this is 2 pi and this is pi, and then this must be pi over 2, and this must be negative pi over 2. Then compared to the original function, there's no horizontal stretch. So that being said, no period change, no vertical stretch, and no horizontal shift. The only transformation observed from here is the vertical shifting 2 units up. Then we can conclude the equation will be y in cotangent again, and then it's with just x. There's no b value or c value goes around with x, but it's gonna be 2 added at the end because this is the d, right? Then to be clear, I can put parentheses over the x there. So then this is the conclusion. This is the equation that tells you what's the transformed equation for the graph there. So this is also one of the practice problem from the section 8.8.